So, welcome back guys, and I do hope you and your family are well. So, we're going to do a little bit of work today on electrical energy, and there's a few things I want to look at, and it's quite a difficult lesson, this one. We're going to look at electrical energy, how we pay for that electrical energy, and we're going to look at power in electrical circuits. So to get you started, I've got a little circuit here and I'm just doing a very simple thing. And I'm going to light a bulb and it's fairly dim. And I'm going to light a bulb and it's much brighter. But that's obvious, you knew that. But what I want you to think about is the energy that this bulb's transferring, shall we say using for now, the energy that this bulb's using, we have to pay for. We bought the batteries. And if this was a big lamp connected into the mains socket, we'd have to pay for that electricity, and as soon as we disconnected, we'd stop paying. But what happens if we have a dim bulb and we leave it on for a long period of time? What sort of money would we have to pay for that compared to a bright bulb left on for a fairly short period of time? So if you think about that one, think about what's happening with the energy. Okay, this lamp is giving out heat and light energy, joules per second. It's a power, okay, and it's giving out joules quite slowly. So we would be paying small amounts every second. Whereas this one is a higher power. It's giving out the joules more rapidly, so we'd be paying more every second. So my suggestion was, what if we have a dim one on for, let's say, a minute? What would that cost us compared to a bright one on for half a minute? So if you think about that, it's sort of obvious, I think, that if we have a dim one on for a minute, we use a small amount of energy, but for a long time, for a minute, and we pay for that. And if we connect to here, we use a large amount of energy every second, but we only do it for half a minute, so we probably end up paying the same amount. So if we're going to look at how we pay for electricity, we're going to need to know a number of things. And we're going to need to know how much energy is being given out per second. Okay, we're going to need to know something about the power. But we're also going to know, or at least have to learn, how long have we left it on for? Did we leave it on for a short period of time? So it's going to be quite cheap to run. Or did we leave it on for a long period of time, and is it going to cost more to run? So we need to know the time we've left it on for. And I'm going to show you a calculation that allows us to take into account the power, the amount of energy given off every second, and the time, and that will tell us how much electrical energy we've used, and then we can work out what they charge us for electrical energy. And electricity comes in specific units. You buy petrol and diesel in litres, and you measure length in metres. And we measure electrical energy that you get from the main supply in kilowatt hours. Now, it's a complicated one, but kilowatt is a measure of the power, and the hours is how long you left that power on for. So if you leave a device that's 1,000 joules a second, 1 kilowatt. If you leave 1 kilowatt on for 1 hour, you've used 1 kilowatt hour of electricity, and there's a price for that. Shall we say 20p per unit, per kilowatt hour? But if you leave 1 kilowatt on for 2 hours, then that's 2 kilowatt hours. So you've used 2 units of electricity, and if a unit is 20 pence, then you've used 2 of them, so that's 40 pence. So I've talked you through how we measure the electrical energy that we use and how we pay for it, but I need to go up to the board now and draw some things so it makes just a little bit more sense. So we're going to look at how you pay for electricity, and I'm going to teach you about the kilowatt hour. So, a bit of a tricky topic, this one, so you might want to pause the video and come back to different bits. So, the first thing we need to know is if we have something that we can switch on. I'll draw a lamp here. And let's make that lamp a really bright one, the sort of one that would be like a floodlight. Okay, so its power will be 2,000 joules given out every second, so we call that 2,000 watts. Okay, so that's going to be a really bright light. Is it going to be expensive to run? Well, I hope you say, don't know, FJ. It depends on some other things. It depends on how long I leave it on for and how much each unit of electricity costs. But to do the calculation, you need to get the power of the device in kilowatts, okay, thousands of watts. So, for what we're going to do today, we're not going to talk about this as being a 2,000 watt lamp. We're going to call it a 2 kilowatt lamp. Okay. It's also worth noting what would happen if we had a light bulb that was dimmer. Okay, maybe we had a light bulb, still quite a bright one. It would be a really, really bright light in your house, but maybe it was just 300 watts. Well, it's no good for what we're doing today. We pay for electricity in kilowatt hours, so everything's got to be in kilowatts. So how many thousands is that? Divide by 1,000, 0.3 kilowatts. So the first stage of this teaching is for you to realise that when we do paying for electricity, we need to do everything in kilowatts. So I mentioned earlier, when we plug things into the mains electricity, that's the electricity coming into your house, we have to pay for it. And there'll be an electrical meter in your house. Perhaps ask your parents to show you the meter. They come in a range of different types. And this meter, I'm going to draw the reading on it in January. Okay, so maybe the electrical company went to your meter in January and it was reading 1,800 units of electricity. And underneath that, you might notice they write kilowatt hours. Okay, so that's just the reading on the meter. Now, you wait for a while, you use devices in your house, and they come back and read the meter. So January, February, March, so we say April. And in April, the meter reads, shall we say, 3,000 units, kilowatt hours. So I think it's pretty obvious that the electricity people will go, okay, it was on 1,800, it's now on 3,000. So you've taken in some energy from them and you're going to have to pay for it. Yeah, you've used 1,200 units of electricity. Okay, 1,200 units. And a unit of electricity is called a kilowatt hour. Okay, now to make the numbers fairly easy, shall we say that they charge you, okay, 20 pence per unit. Okay, so you look at that and you go, okay, if we've used in this time 1,200 units, and each unit is going to cost us 20p, then we multiply the two together. Okay, and the thing to do in GCSE here is don't go into pounds, just keep it simple. So 2 times 12 is 24. Okay, so doubling that, but it's 20p, so we add another 0. So that's what your bill would be. Okay, 1,200 times 20, 24,000 pence. Yes, you can put that into pounds, £240 if you want, but I would keep it all in pence. Okay, so that's the first way. If you're given the kilowatt hours that you've used, you're given the units that you've used, and you know how much each one is, you can calculate the cost on your bill that you're going to have to pay. but it's a little bit harder if they don't give you the kilowatt hours. You have to do a bit more of a calculation, and we'll look at that now. Okay, so let's look at a slightly different calculation you might get, and this is a little bit harder. I'm going to give you an example here. So let's say that you have a hairdryer. Okay, and you know that hairdryer, it's usually written on it actually, but in the exam it'll be given to you. Let's say the hairdryer is 800 watts. Okay, named after James Watt, steam engine guy. In other words, it's giving off 800 joules a second when you switch it on. Okay, and maybe you use it. Okay, and maybe over the period of a few days, you use it for, well, shall we say 30 minutes? Okay. You've not used it continuously for 30 minutes, but you've probably used it for 10 minutes and then another 10 minutes and then another 10 minutes. So over a 3-day period. Okay, and I'd like to work out how much that's going to cost. Okay, so we need to work out how many units of electricity you've used. In other words, how many kilowatt hours. Now look at my numbers here. Everything's not right. Okay, everything needs to be in kilowatts and it needs to be in hours. So take your watts, divide by 1,000 and turn them into kilowatts. So there we go. Okay, and then make sure that your time is in hours. So take your time and turn it into hours. Now watch the trick here, guys. It's amazing how many people want to put 0.3 in for that. Okay, even worse if it's 15 minutes. It's a quarter of an hour. It's not 0.15 of an hour. Okay, but half an hour. Oh, I've got it. Half an hour. This is 0.5 of an hour. Okay. Now, when I teach this, I purposefully write kilowatt hours in different colours. So to work out how many units you've used, take the kilowatts and multiply by the hours. So you've got 0.8 kilowatts and you've got 0.5 hours. So if you look at that, 0.8 times 0.5 is equal to 0.4 kilowatt hours. Okay, so you get the kilowatt hours by multiplying the kilowatts that you've used by the hours that you've used it for, the time that you've used it for. Isn't it obvious that the cost you're going to have to pay depends upon how powerful the device was and how long you left it on for? Okay, so the final bit to say is, but what do we pay? Okay, well, let's say that 1 unit, yeah, that's 1 kilowatt hour, it costs 20 pence. Okay, so you've got to say, oh, we only used 0.4, so 0.4 of 20 pence, and you can bash that out on your calculator if you want, nothing wrong with that, is 8 pence. Okay, so I've taken you through the whole calculation for kilowatt hours. Convert to kilowatts, convert to hours, times the 2, and that will give you the number of kilowatt hours. Okay, that's the number of units you've used. Find out how much 1 unit costs, okay, and then you can multiply by the cost per unit and get the answer. And stay in pence, it's so much easier to stay in pence, okay? Otherwise people make mistakes, like they say sort of 0.8 pounds or something, and they're getting it wrong. Finally on this one, surely we do energy in joules. I did say to you that watts is joules per second, so why do we have to be all complicated? Well, a kilowatt hour is a lot of joules, okay, sort of in the millions of joules range. And so when you connect up to your house and you have an electrical meter, if that measured in joules, it would be going around incredibly fast. It would be like buying petrol or diesel in drops, as it were, rather than in litres. So instead of using the joule to measure electrical energy in this case, we use a much bigger unit, it's well over 1 million times bigger, and that's the kilowatt hours. So if you were to sit there and look at the electrical meter, it won't be turning really quickly. When you turn things on, it will be going really slowly as you use one unit, then the next. And of course, it'll go less fast if you shut stuff down. Okay? So I'll just end by telling you a quick story. When I was really young, my mum used to get really cross with me. She said, "You've left the bedroom lights on for ages." And then she'd have like an electrical heater or something going. And it was like, "Yeah, well, what does it matter, Mum? I don't care." And, the usual sort of teenage arguments. But if you think about it, the argument on my side was quite a good one. I might have left a low-powered device on for an hour or two, but she left a high-powered device on for maybe an hour. And in fact, if you worked out the number of kilowatt hours for her device, it was very powerful, and she left it on for quite a while. And I left a tiny desk lamp on only for a few hours. So in fact, I was using less kilowatt hours than she was. Though, of course, you still have to pay for it, and it still affects the environment. So, I hope you enjoyed that lesson on the kilowatt hour, and you feel you understand it. Have another look through on the video, because it's quite a difficult concept. And I'll be doing another lesson for you fairly soon. Bye.